Okay, so these guys' notes for Unit 2, a little bit different than Unit 1, so a lot more of our kind of going into statistics as opposed to just knowing the vocab with them. So for an overview, this unit is comprised of analyzing and generating graphical displays of data. So we're going to learn about different kinds of graphs, how to use them, when we use them, what type of data we use them with. The purpose of our studies here will be on correctly drawing data from visual displays. So we're not going to draw anything by hand, but rather we're going to see why we use graphs and how they're useful. So the big goal of using graphs is we never make conclusions from them, but they're a good idea to get preliminary information from our raw data. So to take data and kind of see what the shape is, what the distribution is going to look like, and kind of it guides our next step. And again, the kind of whole idea of, there's an old saying that goes with this, why tell somebody when you can show them. That's why every major news network, every major presentation always utilizes graphs, because they help engage like our visual learning. Alright, so the most important and first shape we're going to cover here is known as the mound-shaped, symmetric, or you'll hear me refer to it as the normal distribution. So it's shown here in a histogram. Key idea here is that it looks like a hill. So the normal distribution is not always going to look perfectly like that, but it's going to be pretty similar. So if we're looking up here, we could see if I drew a line directly down the middle, it's symmetric on both sides, meaning it looks the same. So each side is roughly a mirror image of each other. Again, now we give some leeway with it here. If it's not perfectly normal, we still treat 99% of things in the world as normal because they're close enough for our approximations. The key fact you definitely want to jot down here is that if I have a normal distribution, this is true. So the mean, median, and mode are all going to be approximately equal. So that might mean a few decimal places different, but in general, they're all really, really close to one another. There's no distinctive gap between them. So that is one of the marquee indicators. If I just gave you data, we're going to look at those three things and see what they are. So the mean, median, and mode are all approximately equal. Alright, so going from our normal to the next one here. So these are our skewed distributions, and we think of opposites here. So we have skewed left and skewed right. So if we look, if all of the data is on the right, so see how this one here, the majority of the data lies to the right side? This is actually known as skewed left. So skewed, just think of it meaning backwards. If I look over here, all of my data is on the left side of the graph, so it's skewed to the right. Skew just means like a lack of representation on that side, so it's not technically backwards, I guess, but if you think of it that way, it tends to help. Yeah. Outliers can play a role. Sometimes it's just the majority of data falls one way or the other. So in this case, like I said, so on the left side, this is skewed to the right, skewed to the left. I just said those backwards. Totally ignore what I just said. So if the majority of the data is on the right side, it is skewed to the left. If the majority of the data is on the left side, it's skewed to the right. So again, opposites. All right. Now, with this one, this is definitely something you want to write down. In the case of this one here, we have the mean, median, mode come in exactly two orders. So with our normal distribution, that mound, hill shape type thing, they're all approximately equal. In these cases, we see a larger difference between them, and they follow these orders. So for the first one, mean, median, mode, least to greatest, left to right. So again, when we list numbers, we always think of number lines on the bottom. So every time we use a histogram or any visual display, on the bottoms here, these are number lines. So the x-axis is just a number line. It goes in order. Smaller numbers are on the left, larger ones are on the right. So for our first one, if we're over here, so all my data is on the right, so I'm skewed to the left, the order that would follow is going to be mean, median, and mode. So for this one here, where it says mean, median, mode, that represents when it's skewed to the left. So if you want to write an arrow or you want to write that out for you. So if it's skewed to the left, the order of data is mean, median, mode. Down here, this is going to be when we're skewed right. So for this one, we have the mode, median, and mean. So for our rightmost graph here, that's going to be when we're skewed to the right. We call all of our data there is on the left-hand side. So the mode represented in here is like our peak. It's where the highest bar is in our histogram. So again, if you utilize that to kind of base where your mode off of is, the order is always the same. So if they're not going to be normal, if they're not always going to be the same, you can kind of see it follows that pattern. So mode and mean are on opposite ends, and the median comes between them. So on this graph, again, skewed to the left. So we have mean somewhere in here, median, mode. On this graph, we're skewed to the right. Mode, median, mean. So again, they follow that type of pattern. And the more you get used to identifying where those are, the more you get used to seeing it. That's the easiest way to identify those from data. All right, so those are skewed there. There's two more general shapes we talk about. Neither of them is important as the previous three. Uniform, the least exciting one, is where they all look the same. So here we have, it looks like a rectangle, essentially. Pretty much all data has an equally likely chance of occurring. That one, not very common, not very useful. It's a rare occurrence, but worthy of note. Bimodal, this is where two are distinctly higher. So here, you can kind of see we have two distinctive peaks in the data, so it almost looks like I could cut it in half type deal. That's really the easiest way to distinguish those, is there's two that are distinctively higher than the others. Some other notes about uniform. The mean and median are approximately the same, and we have a very small, what's known as standard deviation. So when we talk about that one, we'll see that a little more once we do some calculations here. So standard deviation is representative of the distance between kind of chunks or partitions of numbers. So when we get more into the normal curve, we'll utilize the empirical rule like you guys seen last year, as well as some more accurate calculations there. So standard deviation, if you have a very large standard deviation, that means there's a lot of variety in your data. You have some very high values, some very low values, and not a whole lot of continuity between them. Smaller standard deviation gives us, it's easier to measure with and it's more accurate, but also means that there's less variance or there's less variety in our data. So if I have a very small standard deviation, that means a lot of scores or a lot of input data is very close together. So the key idea here is I want you guys to be able to see these pictures, identify them there, and then kind of getting used to distinguishing with mean, median, and mode, which we'll spend a lot of time practicing with. All right, so moving on from here. All right, these, not necessarily something you really have to write down a whole lot of, just because, again, by this point in your high school career, a lot of these are probably pretty obvious to you. So a dot plot. This displays the frequency of data over a number line, literally using dots. You've seen these in Algebra 1, you've probably seen them in 6th grade. They're not a super common thing we utilize, but again, it's a visual display that we'll make use of and kind of see how they look. One of the most important uses of a dot plot is it's a rapid way to identify the mode. It's a really easy thing for that just because, again, numbers are grouped literally by only those numbers. So with histograms, we see kind of a bucket or a chunk of numbers in there, whereas with a dot plot, it again visually represents just single numbers. So they're, like when I teach it to my freshmen for one of their tests, like they literally use it just to find the mode. I would suggest you guys using the same. You can get shapes of distribution from there as well, but we'll mostly utilize it as a means of calculating the mode without analyzing larger sets of data. We'll talk about bar graphs. Key idea here, this is only with categorical data. So a bar graph and a histogram look really, really similar, but the difference is bar graphs deal with only categorical data. So it represents the frequency of each category, and it has gaps. Now, I know that sounds really weird right now, but like the easiest way if you look at two graphs to tell which one's which is a bar graph has like physical gaps. Like there's spaces in between the bars. Histograms do not. Bless you. Let me just bigger. See stuff. There we go. Bless you. My apologies, guys, that email didn't send out yet, so it's kind of hard to see some of this, I know. All right, next two are both histograms, but they're slightly different in this sense. So for the first one, a typical, or what's known as a frequency histogram, this is the one that's most commonly used that you've seen. It's with quantitative data. Dot plots are also with quantitative data. They can be used with categorical. It's not very common. For our purposes, we'll strictly be using dot plots with quantitative. So again, those two ideas of categorical versus quantitative data. The biggest place that comes in was with histograms versus bar graphs when we use each one. But back to histograms here. So we've used them with quantitative data. The first kind is the frequency. it represents the frequency of each interval. So histograms have intervals of data. So the bar might represent occurrences between the numbers of 5 and 7. It might be between 100 and 200. It all depends on the scope and magnitude of our data. Key idea here, it has no gaps in it. So the bars are literally physically up against one another. You can see them touching. There's no gaps like we'll see with our bar graphs. Here, again, the frequency one, it's just a count. So the x-axis represents the different number values that can occur. And the y-axis represents the frequency or number of occurrences within that interval. So if it goes up to 5, that means 5 values fell within that interval. The relative frequency histogram, this one's less typical. It's also used with quantitative data. So if you have a histogram, you know it has quantitative. So this represents the frequency of the interval in percentages or decimals. So it's a proportion of the data within there. So a frequency has literal numbers like 5 fell in this interval or 10 fell in this interval. The relative frequency will have decimals. So it might say 0.32 or it might say 38%. So it tells you what proportion or what chunk of the data fell in there. They're very easy and very versatile. You can switch back and forth between the two fairly easily. Their shapes will also look very, very similar as well. The last two, we got stem and leaf. Chances are you did a lot of these by hand in your time in junior high. Exciting thing, we'll never do them by hand in here because it's tedious and there's faster ways of doing it. So it breaks quantitative numbers down into a stem and leaf. So it breaks it down by usually the base, whether it's base 10 or base 100, in the sense that like the number 15 is represented as 1, and then there's a line and then a 5. So they're interpreted really similar to others, just a different perspective. They're kind of useful for getting shape of displays. They're okay for finding the mode. A dot plot's a little quicker. But again, we'll cover them very briefly. And then the last one is going to be a box plot, which you've also probably done a million of. This is, of all of these, the box plot is probably the most useful in statistics. Specifically the one we'll be utilizing in Geogebra. It breaks down the data much further than all of the above ones, and we can actually make a lot more conclusions from it just by the way they're calculated. And we'll get more into what we can do with those later on in the unit. So that's kind of the most important. Those other 5 are pretty simple, I guess you could say. Once you get used to a few of them, they're easy to generate and read. The box plot, very easy to generate with the program we utilize, but a little more in-depth in the analysis. Okay, so I'm going to go through these and I'll pause so we can write them down here. So these are some of the definitions we'll utilize here. So we have shape, center, spread, and outliers. The shape, so we've already talked about these. We have mound-shaped or normal, skewed left to right, bimodal, and uniform. So those are kind of the first characteristic we talk about with data is what shape it has. The center, it's our mean, median, or mode depending on what type of thing we have here, so what type of shape. It's where the majority of our data is located. So in normal distributions, we like to utilize the mean for that. In other distributions, so if it's skewed, we'll utilize the median. The only time you use the mode for the center is if you have categorical data, because it's that's the only one you actually can get. So if you have categorical data, you can't calculate the mean or median because they're just like letter answers or favorites. So if I gave you guys a poll of what's your favorite pet, we could not find the mean or median, so our center would be the mode there. For mean and median, when we have quantitative data, again, if it's skewed, we will utilize the median. If it's symmetric or if it's normal shape, those mean the same, we would utilize the mean. For the spread here, this deals with how kind of vast or spread out, I don't want to use the same word twice there, the data is. If we're looking at certain values are distinctively different from one end of the spectrum to the other. So basically, is there a huge variety of things? So if I was looking at test grades, your guys' test grades were actually pretty normally distributed, with a few categories of outliers there. But in general, if I were to eliminate those outliers, then we could go ahead and see kind of a better look there too. So spread just kind of deals with how vast the range is or how many occurrences you have of a low-end number versus a high-end number. And then outliers, this should be a term you're fairly familiar with. It's data that doesn't fit with the rest. And again, we'll kind of get more into those with box plots and identifying them that way. All right, so last couple examples here. We're just going to look at these and we're going to answer some questions about them. So looking at this one, what type of graphical display is this? It's a dot plot, right? So right here we got dots. As soon as you see physical dots, regardless of what color they are, it's a dot plot. You'll notice the key indicators here are the number line. So the numbers are distinct. It's the number 12. It's the number 15. There's not a whole lot of, gaps in data. There's not a whole lot of chunks or intervals we work with. So the main use of a dot plot is a rapid way to identify the mode. Yeah. So this will be our sole purpose of dot plots, is picking out the mode. If we had to look at this and tell me what the mode is, what is the mode, the most frequently occurring number? 10, right? Because we see it, it's literally got the most dots. What's nice about computer programs is, as you can see, they calculate the dots at exactly the same distance between them when it's plotted. If you do this by hand, it's usually a bit more annoying. So again, that's what we'll utilize there. The shape of this. So if we're looking here, if you think about tracing over it, it's going to be pretty close to a mound shape, or pretty close to symmetric. We see we have a little more data over here, or like maybe it's a little to the left. When we talk about skewed, it's going to be distinctively skewed. So if I were to, again, the easiest way to guess the distribution, or estimate I should say, is if you literally just trace a hill on it. If it looks like it fits pretty close to a normal distribution, we're going to call it normal. Now, since it's a normal distribution, it's quantitative data, right? I see numbers there. We said it fits the normal. So therefore, the center is going to be the mean. So I'm not looking for a number answer here. You can give a number answer. So if you said anything between like 9 and 12, I'd give it to you. But the easiest way to answer those questions is just you're saying mean, median, or mode. So the center here would just be the mean because it's close to the normal distribution. Spread, not too concerned about it here. We could see that our data falls between 6 and 19, so it's not terribly spread out. There's no outliers here, so you can kind of see it there. An outlier with a dot plot, we would see like one dot like chilling like way over here, or like way over here. With a dot plot, it's pretty easy to calculate. Again, we'll get into like definitive calculations of those later on. Yeah. A little gap here, like 15. Nothing. It just happened to be no values of 15. All right. Looking here, what type of graph do we have here? Bar graph, right? So the reason it's not a histogram, first off, we look, these are the gaps I'm talking about. Like there's physical gaps between the data. So if you see gaps between them, it's a bar graph. Also, we could look at the bottom. That is not a number line. It says option A, B, C, D, and E. Or it could say cats, dogs. It could say different brands of cars. If it's categorical data on your x-axis or the bottom bar, that's going to be a bar graph. So here, our shape, what would we say here? Does this look normal? If I draw a hill here, does that make any sense? No, right? So it's definitely skewed. Is most of my data on the left or the right side? To the left. Therefore, it is skewed to the right. So this is over here, so it is going to be skewed to the right. If I switch the order of those bars, then it would be skewed to the left. But again, since all of our data falls there, that's going to be skewed to the right. For the spread here, again, I just want you to kind of identify. A spread, I'm more so looking for like the descriptions of the data. So does one thing occur way more than the others? In this case, this one definitely occurs a lot more than these, right? So you could say that one category is distinctively higher than the others. For outliers, same kind of idea. This is definitely like way different than the others. That would be considered probably an outlying category, like the most popular category. With bar graphs, I'm more so concerned with your interpretation of them. We'll calculate percentages of data. So what percent of people chose a given option over another. Again, outliers we'll touch more on when we get to box plots. Bad scaling. Fix that. Okay, looking at this one here. What do we got? It's a histogram. Right now we got to make two choices, either histogram or relative frequency. So how do we tell the difference? The bottoms are going to look the same, right? So we have quantitative data on the bottom, so I know it's a histogram. Now, when I look at the y-axis, are these numbers or decimals? Numbers. Therefore, it is a frequency histogram. If they were decimals, it'd be relative frequency, which we'll see as we move on here. But again, so this would be our frequency histogram. Is the typical one we utilize. So the shape of this one, if I trace it, is it approximately normal? Yeah, right, that looks pretty hill-shaped. So it's not perfect. There's a little more up here than there is over here. But again, if I traced it, there's no distinctive skew in one direction or the other. So in this case, we would say the shape is going to be normal, or you could say symmetric or mound shape, but get used to saying normal. The spread here between 19 and 3, that's kind of where all of our data falls. I don't see any distinctively like way out there categories with outliers. There's no jumps in the data, so nothing to really note of spread or outliers. The center here, since we're normally distributed again, our center here would be the mean. So if it's skewed, it's the median. If it's all kind of in the same area here, we're looking at the mean. And again, if you want it like number-wise, it would be somewhere between, say, like 8 and maybe 12. So if you're giving me a number interval, and again, I'm kind of cool with both of those, be between 8 and 12. This one? This, right, so this is going to be the relative frequency. So frequency has a y-axis with just numbers. This one is relative frequency, because again, we have numbers on the bottom. Now, it doesn't matter if these are decimals. In both a histogram and a relative frequency histogram, you have decimals on your x-axis. The key indicator of the difference is your y-axis here. So in this case, we could see that we have decimals or proportions, likelihoods. So there, we have our relative frequency histogram. Shape again for this one. If we draw it over here, it's still pretty close to mound shape. So this would also be normal. Again, most distributions we deal with will be normally distributed. So again, maybe a little more data over here, but not distinctively so much. Again, pretty close to our normal distribution there. Spread, numerically, we're between 59.95 and 75.95. Not a huge variety of data there. So again, everything's fairly close together. There's nothing that's way higher or way lower. And no outliers, again, because everything is pretty continuous here. There's no like big jumps of intervals. All right, stem and leaf, the least exciting graph of all time. So things that stem and leaf come with, you'll see a key. So they'll always identify to you how to read it. In our program that we utilize, we'll do that as well. So here we have data like 68, we have a couple 91s, we have two 100s, some 85s. So again, this is useful to look at shapes of distribution. It's not the most ideal, but it's useful. If you turn your head sideways, you can kind of look at the shape that way. But we would use histograms usually for that. So here, this one would give us a little bit here if we graph this as a histogram of a skew. But again, not distinctively. Basically, it was just in here to review with you guys how to read these. And lastly, we have our box plot. So this is generated in the program Geogebra, which I wanted to do for the big reason of showing you what the outlier looks like. And the outlier is there. It's that X. What's cool about the program is it literally calculates for you what's known as the upper and lower fence, or a modified box plot. So instead of doing a bunch of calculations by hand, we utilize this program because it just calculates it for us. So it adjusts our box plot, it adjusts our maximums, minimums of the box plot itself in order to determine what outliers are. We won't really do like a shape of a box plot. It's kind of a little more hard to distinguish there. Histograms are better for getting shape. Again, that's where we'll make a lot of our conclusions from. So on tests, I'll give you a set of data. You'll be able to determine which is which, so we'll get used to using which graph for which. And again, once you get that down path, it makes the data analysis piece of this a bit easier. Key idea with box plots is this is how you find outliers. They literally show up as red dots. Alright, this is where we're actually going to start at tomorrow. So again, through this, we just kind of covered all the vocab for the unit. Tomorrow, we'll start with actually going ahead and analyzing our data. Okay, so what we're going to go through today is just in general how to analyze data. So we're going to go ahead and talk about how to make a stem and leaf plot as well as a few other different graphs. So just basically get you guys the tools you need to go ahead and create those as well as do some calculations. So in our scenario here, we have what does it take to win at sports? If you're talking about basketball, one sports writer gave the answer. He listed the winning scores of the conference championship games over the last 35 years. The scores for those games are below. So again, reasons why we don't want to do this by hand is if we take a look here, like this is a large amount of data. Calculating things like standard deviation by hand are super time consuming, even with the use of a calculator. So we want to use a program to expedite that, as well as even mean. This would take a while. You're likely to miss a number. So the way we're going to do this is we're going to open up to Geogebra. Now this is your default view. So the first thing we want to do is go ahead and click these 3 bars here in the top right corner. And then we want to change our view. So when we go to view here, this lets us choose what panels kind of pop up. What we want here is going to be the spreadsheet. So go to view, click spreadsheet. We really don't need the graphics thing, like we can actually kind of get rid of that. So if you want to uncheck graphics, that's okay too. It just kind of spreads things out more for you. And you can kind of click off it. So again, big one is view, spreadsheet. Graphics is kind of an optional feature as of now. So what we need to do here is enter in our data. So we're going to go ahead and type all of that data in. Now, you can do it over different columns. I try to usually separate if I'm doing problems just by columns, like data set 1, data set 2, so on and so forth. For this problem, we see we have a pretty large amount of data, so I'm going to type it all in one column, but know that you could type it in others. It doesn't really make a difference. So I'm going to freeze this up on the board just so you guys don't have to minimize your screens. And I'm just going to go ahead and enter that into column A of Geogebra. Okay, so once we have our data typed in, and again, for the sake of the example, if you don't have everything typed in yet, that's totally fine. Just have a good chunk here to work with. So let's say I had stuff like this. Let's say I had a bunch of stuff in different columns, wherever it might be. I can highlight all of this. So if you chose to type your data in like a couple different columns, that's totally fine. You can highlight and kind of choose as many as you want. But if you did what I did and you just kind of put it just in column A, there's a bit of a shortcut to that. So a couple different ways you could highlight the data. You can either left click and then drag all the way down. But if you had everything, say, just in column A, you could also just press the A on top and it'll automatically highlight everything. That's just kind of the easiest way to get it highlighted. Now, once you've identified to the program what data you're using, in order to generate our graphics, get our descriptive statistics all at once, we're going to choose this button in the top left corner here. So it's a histogram. Now, if you're not in there, like if I don't have this highlighted, this doesn't always show up. Like if you have graphics open or a variety of other things, it automatically turns into other buttons. But again, once you've selected your data, just click here, and you are choosing the very first option here of one variable analysis. Once you choose that, your histogram should pop up on the side there. So, looking at this, it defaults to a histogram here, but we can make a lot of different displays just from this process. So we can adjust here. If we wanted to look at if I made more buckets, so on histograms, if I move this down a bit here, we can see the number line on the bottom there. So if I were to transcribe this onto paper, I'd want to include that. But again, for our purposes, I'm more concerned that you can analyze this, not draw it nicely, I guess. You can adjust how many of these bars or buckets there are with this slider up here. So you could change it. So when you're describing the shape of a histogram, sometimes it helps to move it around a bit just so you guys can see how it looks in a variety of ways. In general, what shape would we say this has? A hill, right? This is pretty close to normal. No matter how I adjust this thing, I can see that my peak is pretty much dead center here. And both sides are close enough. Like these are really symmetric here, right? These ones a little different, but that's okay. And even when I adjust it, it's still keeping that hill shape. So even here, we still see it's pretty symmetric about both sides. So again, if I was looking at shape, a histogram is usually your best method for doing that. We can see that this is a frequency histogram because these are whole numbers on the side. It's representative of how many items occur in each of these buckets. So when we think about a bucket, down here, so this if we look between 105 and it's like maybe 113, what this represents is how many numbers occur between those two. So as you adjust it, you'll see that that x-axis adjusts a bit as well. So it changes where those bars line up, where each of our buckets occur. So if we're looking for shape of data, I would suggest using a histogram. If we wanted to look at that stem and leaf, we could go over here to stem and leaf plot. And as you can see, it literally just creates a stem and leaf plot for you. So it even includes a key. So it's saying that 3 line 1 means 310. So it's giving us that identification of how to interpret these numbers. As we move around here, let's see, we got a dot plot. So a dot plot is most useful if you're trying to figure out what the mode is. So we can see here, whatever that number is, it should be around something between like 111 and 112 maybe, so I could kind of comb my data and look for it that way, just to kind of see which one is going to be the mode. We won't use normal quantile plot. This is just another way of kind of determining. Basically, if the line goes through most of the data, it's considered normal. So another good way of determining if something is normal is looking at this. But histograms usually get the job done there. We won't use bar chart just because it makes one, but it's really kind of ugly here. And it's also not appropriate to use because this is not categorical data. What else we got here? Dot. And our box plot. So box plot, again, we talk about here, this kind of gives us if we have any outliers. So outliers are signified by a red X occurring on either side here. We don't have any, and it won't hide them from you. If they exist, it'll zoom in and out accordingly so you can see them. So there would be no outliers in this data. Basically, if it's normal, you want this to look as centered as possible. So this midline here, which is the median, we want it to be like perfectly in the center, but this one's pretty close, and it looks about the same on both sides. So again, kind of backing up our idea that this is normal data. Last thing we're going to kind of cover today is just going ahead to get those descriptive statistics. So these are all of our visuals. To get the statistics, we actually just go up here and click on this. So it's the summation symbol with an X next to it where it says show statistics. When you click that, for some reason these disappear. If you click something else, they come back. Like it's not like they're gone forever. But these are what we're looking at here. So key ideas here, we have our N, which is our sample size. And these are calculations we're going to use the entire year. So this is one of the most common calculations we'll use in every unit of this course. Mean, so it tells us what our average is, our expected value here. Again, you'll hear me say mean. It's 113, so that's the average of the data set. We're not going to use this one here. We're just not. It's the way the program calculates. We always want to use S. So for any time I ask you for sample standard deviation or to calculate standard deviation, you're always going to use S. It has nothing to do with it being a whole number in this example. That just was a random occurrence. But again, so if you're highlighting things here, make sure you notice or note to always use S when you're calculating standard deviation. The next couple of bits of information we might need are these last 5. We won't need these. This is the summation of the X values, the squared summation. Like we're not going to use that data. But these last 5, here's your minimum, Q1, median, Q3, and your maximum. Those will be useful when we work with box plots a little more later on. But in general, just know that this is kind of the methodology for getting all of our analytics or all of what's known as our descriptive statistics. Okay, so that was our data set. We kind of just went through how to get everything. One more slide we're going to do in this section here is just a brief review of how to tell the difference between a bar graph and a histogram. So histograms have continuous intervals, so we see the numbers on the x-axis. Bar graphs have data sets or bins that are spread out, and again, they're that qualitative or categorical data. So similar to the examples we've seen yesterday, on the x-axis of a bar graph, it's going to be categories, or it's going to be multiple choice options. Or with histograms, we're always going to have numbers down there. All right, that's going to be it for this section here. All right, so going through our last chunk of notes here, I deleted a couple slides here, bless you, just to kind of focus on the key ideas here. A couple of them we already kind of talked about, so no need to include those. What we're going to start with here is just interpreting this graph, so pulling a little bit here just to review on how to get percentages from things. There will be a couple questions on your guys' exam that involve that, so just asking, okay, what percentage of data is in this interval or in this category. So looking at this graph here, I'm going to blow it up a bit just so we can actually see it. Give me a second here. Where did that go? Sorry guys, 1 second here. Just going to put the questions to the side and then blow up the graph so you guys can see. Okay, that should be a little better. All right, so for our first question here, how many students are enrolled in chemistry? How many we got? 140, right? So we just look at that. That's our frequency or our count on the left side. Is this a bar graph or a histogram? Bar graph, right? It's categorical. We have different categories. It's not a number line on our x-axis. Okay, now, so that one's pretty self-explanatory there, right? Just count the number. Now we're looking at what percentage of students are in physics. How would I figure out what percentage of students? So first thing we need to figure out is how many total students there are. So there's other questions in you guys' homework that they give you some histograms, and they're like, okay, which one had more volunteers or which one had more in the survey. So to figure out the total number of participants, I'm going to look at each of those bars and then figure out what the total is. So for biology, we had 220. So that means I have 220 plus. You guys could do this in Geogebra too, or just use any calculator for that matter. Next one, I got chemistry. I got 140, so I'm going to add that in as well. Physics, I have 60. Earth science, it's in between 200 and 220, so I'm going to go 210 there. And again, now if you guys estimated that on the test and I seen you know, okay, you were really, really close, but you just went like, say, 215 or something, I'd be cool with that. On your guys' exam, I tried to make it as obvious as possible which number to go with. And if you're unsure during the test, like, just ask me. I have no problem doing that. And then astronomy, we got 100 students. So I have 730 total students. Now, we want the percentage that are in physics. So to find percentages, just like, again, when we get into our next unit of probability here, just the number divided by the total, right? So I have 60 students in physics. So to figure out the percentage of students, I would do 60 divided by my total, so that's 730. And my answer is 0.0821. So let me go ahead and just type this up real quick. 0.0821. So we did 60 divided by 730, and we got 0.0821. So what is that as a percentage? 8.2%. So ways you could do this, you could either multiply by 100, or if you remember the rule of just moving to the right twice. So if I move that decimal over to the right twice, I'd get 8.21%. And 2 decimal places is cool for percents. If you look into calculator answer, I think it went a bit further. Like it gave us kind of a lot there. But 2 decimal places for percents is always cool. All right, going on to our next question. What percentage of students are in biology or earth science? So if I'm looking here, we know we still have 730 total students. So that number's not going to change because we're still working with the same graph. Now, or probability or counts mean we have to include both. So we had, what was it, biology or earth science. So I need to figure out the total and then combine. So biology here has 220, so I'm going to start with that. So 220. And then I'm adding on, so that's my biology, and or earth science. So here we said, let's see, 210. So if I add those together, I have 430 total students taking both of those courses. So I'm going to have 430 divided by 730 to find out my answer here. So that gives me 0.5890. So 430 divided by 730. What was it? 4890? That's what you said? Wrong thing. Yeah, 5890. There we go. So again, as a percentage there, I move it to the right twice. So we got 58.9%. Or 58.90. Either way, same thing to me. So again, just a review of when you're finding percentages there, you need to figure out the total number of participants, the total number of pieces of data in our study. And then again, the other thing there, or just means include both of those. So add them together and then divide by the total. All right, moving on. Okay, and on your guys' exam, you might have questions that give you the data in a table. So it's a little easier version of this. So I can either ask you these types of questions coming from a graph or from a table where it just tells you how many people are in each category. A little bit of a review here. We talked about this already. This is like kind of a summary slide. When I ask you which measure of center is best, or I say which measure best characterizes the data. So just a bit of a review here. Here's what the mean is. So we're calculating GeoGebra, but again, just kind of the literal way of what it means. It's our average. The median is literally the middle number when all of our data is in order. Mode. So just a brief review here. A couple of you guys asked me about this yesterday. when we're calculating the mode, I would suggest using the dot plot. And then when we're answering if there's a mode, there's either a single mode or no mode at all. So if I had two numbers that occurred at the same amount of times here, let me bring up Geogebra real quick here. Give me a second, it's not going to work. There we go. So let me just do one real quick for an example of this. Spreadsheet. So if I just made up numbers real quick here for the sake of this, let me get a dot plot. So again, if you're looking for the mode, easiest thing to do is look at the dot plot. Now here, I have two numbers. I have specifically the number 1 and the number 2 that are occurring more often than the others, right? Move this down so we actually see that. There we go. So the number 1 and the number 2 occur significantly more, but they occur an equal amount of times. So in this case, if I asked you what the mode was, you would say there is no mode, or none, does not exist, any variation of that. So you either have a single mode, like if I had one less of these and ran the simulation, or ran the dot plot here. So here there would be a mode. Here 2 would be the mode because it occurs more than all other numbers. So again, just a reminder there, you either have a single mode or no mode at all. We talked about this, but again, just wanted to cover it one more time. So which is best? So if I give you categorical data, so if it was a bar graph like we've seen on the last slide, and I said which measure of center is best, you would say the mode because it's categorical data. Anytime it's categorical, so anytime you have a bar graph, the mode is always your only real measure of center. For quantitative data, it's the mean if data has no outliers, which means it's not skewed, right? So if the data is not skewed, so data is normal. And then it's the median if there is outliers or if it is skewed. So data is skewed. So again, if I give you a graph and it's skewed, so if it says something along the lines of, if I said the median is higher than the mean, then you would use the median. If I said the median is lower than the mean, you would use the median. Because again, those are we talked about in the first day there. If the median's to the left or the right of the mean, like a significant portion, then we consider that data skewed, and our median is our best measure of center. If I gave you something with the mean and median roughly equivalent, so really close to each other, then it would be the mean is our best measure of center there. So if it's normal, we use the mean. If it's skewed, we use the median. This is just kind of another example if you guys want to work through here. This is just, again, kind of making a histogram, but we already covered that in the last set of notes. So kind of looking for the shape of the histogram. But let's just go ahead. I'm not going to utilize this data. I'm just going to, because this is a lot, I'm just going to plug some in here. So let's throw some more numbers in here. So I'm literally just typing random numbers for the sake of convenience here. There we go. Let's get a nice histogram here. Okay, so here's a good example of a histogram. So again, we utilize histograms to talk about shape. So let's say I wanted to classify the shape of this. What shape would we say this had? Normal or skewed? Skewed. Skewed which way? So I have most of my data on the left, correct? So what's that skew called? Skewed to the right. So we always think opposites, right? So this is definitely skewed, right? My peak is distinctively on one side of the graph. So here this would be skewed, and it would be skewed to the right because the majority of my data is on the left. Now if we had it the other way, if this was flipped over, then it would be skewed to the left if the majority of data was over here. So again, think opposites there. Wherever the majority of your data is, or wherever your median, your peak is, it's skewed in the opposite direction. So it's on the left, therefore it's skewed to the right. If we wanted to pull something from here, so if we look down here, on your guys' test, I gave you like very distinctive intervals. So let's pretend these come to nice whole numbers, right? So if I want to find the percentage of data in this middle bar here, right? So similar to with the bar graph, we'd figure out what the count is here. So okay, I have 4, the frequency is 4 for this middle bar. So if we wanted to go ahead and find out what the percentage of data, on the test, like I said, I made it come out to easier intervals. So let's just say I told you the interval was 4.5 to 6.5. So we're looking at this middle bar. So for here, I have 4 total in there. and then the total I would add up. So just like with the bar graph we already did, we'd figure out the frequency or the total thing here. So I have 5 in this bar, so I'm just going to throw some parentheses in here. 5, this bar represents 2. We said we had 4 here. Another 2, and then a 1. So for the percentage in there, we would have 28.57. So again, as a percent, we'd move it to the right twice, so it would be 28.57%. So you can expect those percentage questions both with bar graphs, histograms, as well as from a table. But again, it's the same method for solving, just the interpretation side there. Bless you. All right, this, I just wanted to give you guys these rules formally. So we covered in the last set of notes how to get all of these. So again, I'm just going to, let's use this data so I can copy and paste. Maybe that'll work. Let's go ahead and get rid of what I have here. That's going to work. All right. So not the most convenient thing to highlight because it's horizontal, but it'll work for us here. So I just copy and pasted that data in. Now I'm going to go ahead and highlight it. It lets me. There we go. Let's go ahead and get our data here. All right. So really weird looking histogram, right? Now let's go ahead and get some numbers from it here. So what this is asking, these are different descriptive statistics. These are also the 6 pieces of data you're going to have to find on your guys' exam. So there will be a question where I give you a data set similar to this, and it asks you to calculate these things. So the way I wrote this is these are the ones it's asking you to find. Median, or mean, median, mode, sample standard deviation, range, and IQR. What I wrote next to these is how exactly to get them in GeoGebra. So the mean is labeled as the mean, median is called the median. The mode, I said visually inspect the data. The easiest way there, again, would be our dot plot. That's going to kind of be your method for that, or the quickest. Or you can just look yourself and find the mode. The sample standard deviation, you want to use that S. So remember, we're looking for S for sample standard deviation. It's labeled as that. Our range is the maximum minus the minimum. And the IQR we calculate from Q3 minus Q1. So where to see those at in GeoGebra? Similar to how we did yesterday, we go ahead and click this button here. So we ran our one variable analysis, we highlighted our data, and I'm clicking this to show the statistics. So our mean for this data set would be 43.6667. On your test, I may have rounded it a bit more, or it may come out to a whole number, but again, it's labeled. Sample standard deviation here is my S at 18.3439, and then median down here at 46. And then again, our calculations, so range, we would just do maximum minus minimum, so it'd be 75 minus 17. And then for the IQR, we would do Q3 minus Q1, so 57.5 minus 28.5. So again, just kind of going through those, getting those different statistics. All right, so this is all we kind of talked about already. Again, I just wanted to give you guys this a more formal section of the notes. All right, so a few more slides here. This is just what we talked about kind of with box plots, so interpreting exactly what they're telling us. So here, this would definitely be a useful diagram to sketch down here. I wouldn't copy all of these words down. I would just use min, Q1, median. I can highlight these for you guys. Let's see if I get those. Draw, highlighter. So I would just label them as min, Q1, median, Q3, and max, just because those are going to match up the same type of vocabulary you'll see with your guys' test as well as with GeoGebra there. So the key idea here is how these quartiles are how they break up. So in between the minimum and Q1 is exactly, or for our purposes exactly, 25% of the data. In between the Q1 and the median, 25% of the data. In between the median and Q3, also 25% of the data. And lastly, between Q3 and the max, we have 25% of the data. So this example here is what a normal distribution looks like with a box plot. Now, how we judge whether or not it's skewed, we read it the same way as we would with a histogram. So if this is moved over to the right, it would then be skewed to the left. So all we're looking for here when we're getting the shape of a box plot is kind of where the median is. So if it's really crunched over on this side, if it looks really small there, that means the majority of the data is there, and it would be skewed to the right. If I shifted everything to the right, then it would be skewed to the left. So again, it's the exact same interpretation as with the histogram. You just look at where the median is. The key idea here is we're going to do a little bit more math with this so we can get a little more data or a better feel for things from this box plot. So we're going to utilize these ideas of 25% in the next few examples here. So pretty much anytime you make a jump between points, or between these 5 markers, it's 25% of the data. Alright, so using this rule a bit, if we look at our next one here, let me just do this real quick. Control copy. I'm just going to throw them in a Word document so we can actually do the work here and you guys can see it. There's one of them. Alright, so these are going to be 2 separate problems. So how this would look on an exam, because I would give you these, except I'm not going to write the 25% in here. That was just for the sake of ease in the example here, so we can kind of translate it from box plot to how we would do the problem. So I'll give you these descriptive characteristics. I'm not going to have you calculate them. It would give you the problem set up. Okay, it's going to tell you what the minimum, Q1, median, Q3, and the maximum are. This is not a multiple choice type question. It's going to, the directions, let's see if I put them on here. I did not. But the directions on the test would be similar to figure out the percentage of data in each interval. So to do this, we're really just looking at adding. So between 10 and 54. So if I start here, 1, 2 jumps. So I cover 2 of those 25%. So what is 25 plus 25? 50. So in this first interval here, we're looking at 50%. B, from 23 to 157. So I'm starting here. Now again, it helps if you write the 25% between these numbers. So this is, I set this up so you guys could have a good strategy on how to do these and ensure you're doing it right. So for each jump you make, you add 25. So 23 to 157, I make 1, 2 jumps. So again, 50%. 54 to 157. So I'm starting at 54, I make 1 jump. So what percentage of data is in there? 25. 157 to 243, 1 jump, 25 again. And good. 1, 2, 3, 4 jumps, going from one end to the other. So that's 100% of my data there. Bless you. Good. So 34 to 77. So I'm starting at 34. I make 1, 2 jumps. So there I'm going to have that 25 plus 25. So we'll get 50% there. So I started here at 34, and I made my jump. So 1, 2 jumps to get to 77. 25 plus 25 gave me 50. 34 to 51. We're just looking at 1 jump there. So that's going to be 25%. 77 to 130. 1 jump, 25%. 51 to 130. 1, 2 jumps, 50%. And 34 to 130, I make 1, 2, 3 jumps, so 75%. You should notice that there's exactly 4 answer choices for these: 25, 50, 75, or 100. All right, heading back in here. Real quick here, just want to talk a bit about analyzing box plots. So if I were to give you a question like this, I could ask you things along, are the medians equal? No, right? So here's the median on this box plot. Here's this one. They're definitely not equal, right? This one's about 18. This one looks like it's maybe 14, 13, somewhere around there. I could ask you if the IQRs are equal. So that's Q3 to Q1. That's the boxing part. Are those equivalent? No, right? Different distances. The ranges are different. So the highs and the lows are different. Again, so just basic interpretation of box plots. You can calculate things from these. So if I asked you of the range for the girls, I would look here. So the highest is about 37 maybe, 36. Lowest is 3, so we could subtract those. So again, just knowing where those key ideas are on a box plot, which is the exact same as the diagram here. So minimum, Q1, median, Q3, and max. And the last thing we're going to talk about here is I'm just going to go open up the website for this one. If you click this link, it'll take you there. I already have it open. It's just talking about misleading graphs. So first off, this website, when you're in college, I highly suggest it. It's statisticshowto.com. It has literally every single thing you could imagine in here, just an alternate explanation. So if you ever don't understand something I said, this would be a great resource. So what we're going to do is we're just going to watch this video real quick together here and then kind of talk about it. Also, this book here is awesome. It's a free PDF. Well, you can find it as a free PDF, I should say, or buy a hard copy if you'd like. But basically just going to go through a couple of these for us here. Just really bad graphs and how they can be misleading. Alright, so once all your data is organized, we're going to go through a couple things in Excel here to make your life significantly easier. If we look at our worksheet of what we're turning in, you should have already completed all of this. So this part up to your questions should be done. That should be all completely filled in as you had this week in class to do it. As we go into here, so now we're going to go through how to go ahead and start organizing this. So you'll notice each question deals with breaking it up by grade level. So we have our dot plots for freshman, sophomore, junior, and senior. You'll notice there's no further analytics there with our categorical data because, again, we're just looking for the most popular item in each of those, or two most popular perhaps. The key idea here is we'll interpret the trends at the bottom. Since we're dealing with categorical data and dot plots, we're going to go with a specific way to kind of use what's known as a dummy variable. So it's in statistics how we deal with categorical data, but we still want to treat it like numbers because programming something to count words is significantly harder. All right, so let's go ahead and start here with our dot plot. So first thing we're going to do in our Excel file, once you've transferred everything over, is you are going to need to organize this data a little more effectively. So mine's in order here just because that's how I generate it, but let's say that it wasn't. So let's say I had all my digital surveys and they weren't in order, but I want to look at it by grade level. So to sort your data, what you can do is just click on a column. So I would suggest doing everything by grade level because that's how the worksheet's organized. So if we click on the A column here and then right click, we have the options. Oh, it's not showing up on here. Let me see where it's at. Okay, so under the home. Right here. So we click on our column. We go to home. And then on the right side it says sort and filter. So we can sort A to Z or Z to A. It doesn't matter which way. Excel will not natively understand that freshmen are younger than sophomores. So therefore I would suggest an alphabetical sort. It's going to give you this pop-up. It says Microsoft Excel found data next to your selection since you have not blah, 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 blah. We go ahead and click here, expand the selection, so just hit sort. And basically what it does is it rearranges everything. So again, just agree with the default thing there and it'll rearrange things in alphabetical order. So again, Excel is not intuitive. It does not understand grade level sorting, but it can sort by the alphabet. So again, we can get our various orders here, or at least chunk together our different grades. After you do that sort, you want to save it. That way you don't have to keep doing this each time. So the shortcut to save is pressing Control-S, or you can just press the Save button, whichever way works for you. So again, now our data is in order. Alright, so when we're talking back to this here with these categorical questions here. So again, we can't take Geogebra, throw in categorical data, and expect it to all of a sudden understand words. So what we're going to do is do a trick. So as we know, there is exactly two categorical questions you asked. You asked, what is your grade level? And what flavor of coffee do you prefer? Those are it. Those are the only two. So if we're looking here, our categorical question 1 was grade level. That one was typed in for you. If you notice, I don't actually ask you to do any type of graphing with that because that first categorical question was just meant to see what type of data we have. It's an organizing tool. So you're not going to do anything besides that sort we just did with the grade level. As we go through this part, this is where we're going to use what's called dummy variables. So we're going to encode our data in a way that we can actually understand what's going on. So the first thing I would suggest is we're going to create ourselves a key. So my possible choices here, I had mocha, vanilla, pumpkin spice, and caramel. So what we're going to do is we're going to replace those different words with a number value. The reason why we do that is because then Geogebra can understand it. Whereas if we just type a bunch of words in, it will have no idea what's going on. So I'm going to create myself a key here and just say categorical key. because when I'm talking about this later on, I don't want to forget which each one stood for. So for my categorical key, mocha was an option. I'm going to say mocha is just 1. I had caramel equals 2. And it doesn't matter what order you do these in. If you had 3 options, use 3. I don't care about the order. It doesn't mean mocha was the most popular. I'm just giving them a number label. You can also use 0 if you want, but for some reason the numbers 1, 2, 3, and 4 are just more intuitive for me. So I got pumpkin spice. I'm going to set that as 3. And then vanilla, I'm going to set as 4. So I'm just making myself a key here just so I remember when I go back to talk about this what those things meant. So then I'm going to save it again. All right. Once I have a key, I'm going to go ahead and start changing out my data. So I'm going to now replace these with these numbers. So we talked yesterday about how to find and replace. So I'm going to press Control, that's the bottom left corner of your keyboard, CTRL, and then F at the same time. What that gives me is this little nifty tool. We used it for some of our data sorting yesterday for cleaning it up. We can also use it for this, so encoding our dummy variables. And again, the term dummy just means like taking the place of. It's actually a programming term. It just sounds goofy. But again, it's a way of looking at categorical data without having to create our own program to do it. So what we're going to do here is we're going to replace. So if I choose the button that says replace, so I'm just going to do this. So I'm going to replace the word mocha. So I want to find what? The word mocha and replace with the number 1. So the find what is mocha for me. Whatever yours is probably different. And I'm replacing it with the number 1. So I'm going to hit replace all. And I notice, okay, it tells me how many I made. Ideally, your data is much longer, so you probably replaced more. So I could see right there, okay, all the words mocha turned into a 1. Now my key says I'm going to replace caramel or caramel, depending on how you want to talk. Either way is correct, technically. With the number 2, hit replace all. Okay. And I said pumpkin spice, which is awful. Don't judge me. I'm going to replace that with the number 3. Okay. And then lastly, I have vanilla. And I'm replacing that with the number 4. Alright, once you've done your replacements, you're good. Again, at this point, make sure you save your file. Now, you notice over here, this annoyingly switched. So, we're going to go ahead and switch those back real quick. I did not realize that would happen. My bad on that. So maybe write your key to the side and then put it in here. So maybe like write it on paper and then type it back in. Luckily here, I think I remembered the order. All right. Okay, so that was the order we utilized again. So maybe write this categorical key on paper before you do the replace stuff, because yeah, that was probably not too user friendly there. All right, but anyways, we got our key set up now. So we've put in our dummy variables for our categorical data. We can always go back to them later if we wanted to, but now we're set up for our analysis. So at this point, we're going to use Geogebra to generate all of our graphs. So if we go ahead and open that up. You can get rid of this keyboard thing. I don't know why that exists, to be honest. So again, to open our spreadsheet, just like we've used before, we click in the top right corner, and then we go to View, and then we want a spreadsheet. I'm going to go ahead and get rid of the graphics panel, just because it eats up less space that way. I don't really need algebra either, but it's not hurt anything over there, I guess. All right, so the first thing we're going to look at is our categorical data, right? So as I'm saying, I need a dot plot for each grade level. So what I'm going to do is go ahead and just start organizing. So we already sorted. I have my freshmen here, juniors, seniors, sophomores, right? And now I need to put them in. So I'm just going to go in order of freshman, sophomore, junior, and senior. I'm going to get it all over at once here just so I can knock this out fast. So I'm going to copy my freshman data. So these are all my freshmen. I had 4 of them. So Control C is to copy, or you can just right click and hit copy. And then I'm going to paste that here by either right-clicking and clicking paste, or you can just press Control V. Sometimes it takes a second here. Okay, so I would definitely use the Control V to paste because for some reason the first time I did it didn't work. So when you want to paste, click in cell A1 and then hold Control and press V, and that'll paste in our data there. You can ignore what happens in the algebra panel. It's not really necessary for us now. So I'm just remembering this is my freshman data. Now I'm going to get my sophomore data. So let's see, I'm going to highlight that, Control C to copy, go back to GeoGebra. Now I'm going to go in B1, Control V to paste. So here you definitely want to make sure that you paste it in different columns, because otherwise if you paste it all in one, it's just going to be harder to work with. So I'm going to separate it by grade level in each column. I'm going to go get my juniors, so highlight it, Control plus V. Oh, I lied. Control C to copy, not Control V. So Control C to copy, Control V to paste, and then lastly my seniors, highlighting, Control C to copy, and Control V to paste. So I've got everything in GeoGebra now. So ideally, again, you have more data. Sometimes if you have a larger amount of data, it takes a second for it to load, so don't stress. But yeah, sometimes it takes a second there. One annoying thing in Excel, which I've yet to figure out a technical fix for, is once you copy something, it has this annoying thing on here, and then when you click other places, it like sometimes bugs out the program. After I've copied something and I'm done using it, what I do is I just click in like any cell here, and then hit Control C again, and like it goes away. So like click in a blank cell and hit Control C, and then that weird box like this thing, like that annoys me because when I start clicking around, I'm like, why is this still highlighted? So if you just click in any blank box so that the cursor comes up and hit Control C, then the annoying highlighted box goes away. I'm sure there's a more effective way to do that. That's just how I've always gotten rid of it. All right. So anyways, as we're looking here, we need dot plots, right? And we already encoded our data, so that's good. So let's go ahead back into GeoGebra now. So I want a dot plot of my freshman data. So I'm going to go ahead, just like we've done a bunch of times now, click on my column A, one variable analysis, and let's go ahead and get a dot plot. There you go. So ideally, your data's got a lot more dots than mine, but again, just kind of what we expect at this point. So I have my dot plot here. Make sure when we snip tool this, we include the number line, because otherwise we don't have a feel for what any of the data means. So again, to get your snip tool, if you go on the bottom left there and just search snip, it will come up and it will look like this. So we're going to go to new. I'm going to make sure I highlight here. So we don't need to include like the word dot plot up here. We're just looking for the graph itself. Give me a second here. I want to get rid of this help thing here. I don't know what that means. Go away. Just trying to get rid of that little thing. Okay, so if you click the box that says help, it'll do like a pop-up you can X out of. It was just really blocking the view. All right, so I'm going to click new. And then go ahead and get my dot plot here with the axis. Then you can either press this button here that says copy, or you can do the Control C thing again. And I'm going to go ahead and throw that right underneath here under my freshman dot plot. So Control V. Maybe make that a little smaller, or you can leave it big. Either way is cool. Don't make it like obscenely small. Like don't make it like this, because then I can't read that. And again, since you're submitting this digitally, I'm not really concerned about how big it is. But again, make it a realistic size. So you don't need to reformat the document. Like I'll know where to look. So don't feel like you got to space it out. If you want to and like make it very readable, that's great. But I'm not gonna grade you on that. I'm just concerned that the freshman dot plot is here under freshman dot plot. And again, I labeled that in these directions here using box plots. Oh, this should say dot plots. My bad. Dot plots. And snip tool into this document in the appropriate place. Then comment on what the data tells you below. So we'll talk about that a little later on here. All right, so then you would go through and do the exact same thing for sophomore, junior, and senior. So for my sophomore data, I would highlight column B, one variable analysis, get my dot plot. And again, snip tool, just like before, put it in there. So at this point, you should have all 4 of those put in once you've completed that part. So what we're looking for here. Now you'll notice that these are worth more points. The reason being because it takes a little more thought to get it done. So with this part, what trends or patterns do you see in the data? Is there a noticeable difference in how grade levels respond? Why do you think this is? Or is it not apparent? So not apparent means all the shapes of your various displays here in that categorical question look pretty much the same. So if I found out that every single grade level preferred caramel coffee, like and it was just that was distinctively the highest point, I could say, well, there was some variation between the other responses, but caramel was the most popular in all of them. Or if each grade level had a different favorite, maybe I could say, well, freshmen really liked mocha, The sophomores like caramel, juniors and seniors distinctively preferred pumpkin spice. Again, that's not like a cover-all answer because I'm not the one looking at your data. So again, if you want me to take a look at that before you submit it, you have plenty of time in class. Make sure you're asking me, and I'd be happy to look at it. But again, it just basically you're looking at the graphs and telling me what's happening. Since this is 5 points and all these graphs are less, again, this should be something that's not a 3-word answer. This should be a little bit longer. At least give me a couple sentences so it makes it look like you did really look at your data. All right, moving on to quantitative questions. So these are the ones we're going to use box plots. Again, if you fix that typo here, it says dot plots here. I just honestly forgot to fix that part. Okay, moving on here. For our quantitative questions, you'll see there's asking for a little bit more, so you're going to get a little bit more of the points weighed in on these portions. What's nice is we don't have to worry about encoding any variables. They're already numbers, so we're good to go. So what I'm going to do in Geogebra, since I've presumably used all this, is just delete it. So if you click on the thing and just hit delete, that's faster than doing cell by cell. But going into here, so we're noticing we're pasting the dot box plot. That's 2 points. You're telling me about the shape. So shapes of box plots. We're going with normal, skewed left, or skewed right. Those are your 3 possible options. You don't need to justify it. I just need to see that you've associated the right word with it. Descriptive statistics. Here, I'm actually cool with a copy and paste to avoid typing it up. If you want to type it up, that's cool, but I'm just going to use the example of copying and pasting to save us some time. All right, so let's go ahead here. We're looking at quantitative question 1. So in my Excel file here, my first quantitative question was how many cups do you drink a week? My second quantitative question was how much will you pay? It does not matter which one you call quantitative question 1 and quantitative question 2. You just need it one of each, which again, had you gotten your questions approved by me, you would have them. So I'm going to go ahead and highlight my data here, Control-C to copy, and I'm going to go throw that in column A of Geogebra. And then I'm going to go ahead and bring over my second one as well, just because I know I'll need it later on. So Control-C to copy, Control-V to paste. And then, again, that nifty thing to get rid of this annoying box that confuses me is I'm going to go ahead and click in here and hit Control-C just to let Excel stop being so concerned. Now, if we're looking here, this is looking at all grade levels as a whole. So if I was curious how that would look, again, I could go ahead and do some extra work and maybe take a look at what that would look like as a whole to figure out on average, would more students pay more or less. But again, here we're concerned about grade level. So instead of copying everything over as a whole, what would make more sense is looking at it by grade level just like we did before. So I'm going to go ahead and delete this. So admitting that I totally copy and pasted that for no apparent reason and against my own directions, let's go back and since we already sorted things by grade level, do it that way. So I'm going to work on one quantitative question at a time instead of trying to expedite things. So for my freshman under quantitative, I'm going to go ahead and highlight just the freshman data, Control-C, and let's go throw that in column A with Control-V. Going back to get my sophomore data, Control-C to copy, Control-V to paste, and junior data, Control-C to copy, Control-V to paste, and lastly our senior data, and Control-V again. Again, to help Excel not be so confused, click a cell, hit Control-C. Alright, so we'll do the one quantitative example here where we kind of get everything so you guys can see exactly how I want it formatted. So we're looking at each grade level here. So we want to deal with freshmen, we want to talk about the shape, and then we're going to go ahead and include those descriptive statistics listed there. So if we go ahead and look here, let's look at our freshman data. So that's my column here. I'm going to go ahead and do my one variable analysis, and we wanted a box plot. So it looks like I got a nice box plot there. So let's go ahead and snip tool it. You can either press new or hit Control-N. I'm going to try to teach you guys as many shortcuts on the keyboard as humanly possible here. So we go ahead and click this. Make sure I include my number line here at the bottom, right? We want that in there. And then copy or Control-C. And let's go ahead and paste that here. I'm going to make that a little smaller because that just looks gigantic. All right, there's my box plot. So 2 out of 2, I included my box plot. Describing the shape of this. What shape would we say this has? normal, right? So when I'm judging a box plot here, it's all about looking where the median is. So if I'm looking at this, my median is always that middle bar. So I have 1 bar here, 2, 3, 4, 5, representative of the minimum, Q1, the median, Q3, and the max. All where this is how we make our decisions. So if this is centered, meaning it's equal on both sides of it, so it's roughly close to the middle, that's when we're going to go with a normal. Let's get rid of that. Let's say now I had something where my median was like way over here, right? So pretend this middle line isn't here. If it was all the way to the left, thinking of our opposites, that would be skewed to the right. So if the median is all the way to the left side, or very distinctively to the left, we say it's skewed to the right. And lastly, if it was distinctively on the right side, we would say we're skewed to the left. So again, just a brief review there. That way you can make sure we're commenting on those shapes, right? But as we said with here, this would be about as obviously normal as we're ever going to find, because it's literally dead center. And again, if yours isn't perfect, that's okay. So again, just make sure you keep the text very, pick a color. Red is easiest because you don't have to do any work. Just so I can see there, so normal. And then for the descriptive statistics, instead of making all the keystrokes to type this stuff in, we're just going to snip tool it. Bless you. So under here, again, to get those descriptive statistics, once I have a box plot, all I have to do is press this button, the summation symbol with an X, to say show statistics. And they show up. So again, to save you the time, you can just go ahead and snip that as such. So if you want to get fancy, maybe highlight what I'm looking for. So I'm looking for the mean, median, and mode, and outliers. You don't got to highlight, because this isn't going to give us all of that. So let's just go ahead and copy that. I'm going to throw it in here. So I can see what my mean and my median are, right? So mine both happen to be 1. Obviously, that's kind of obscure and your data might be different. To find the mode, what graph would be ideal for finding the mode? Which one have we used in the past? Dot plot, right? So I'm going to go ahead and look at a dot plot here. And if we're looking, on my example, my mode is 1. So it's visibly 1, right? Again, you can highlight over the data. If you see that distinctive thing where there's more dots on one thing, you just highlight it and it tells you what number it is. No need to look at the number line and approximate. So I would say my mode here is 1. If you wanted to type the mean here, that'd be nice. But again, for sake of ease, if you just snip tool this, so either snip tool this or just physically type them in, either way is totally acceptable with me. Outliers. What graph do we look at to determine if there's outliers? Box plot, right? Or you could use a stem and leaf plot. Either way, but I prefer the box plot just because we already used it once. So if I have an outlier, it's going to be signified by a literal red X either on the left or the right side. I have none in this one because there's no red X's. So the way to respond to that would be no outliers. So none. Or you could put no outliers. Or you could put like they don't exist. Some variation of the word none would be ideal here. And again, an easy way for me to grade that is I'm going to look at your box plot, and if it shows an outlier but you wrote none, that's not correct, right? If there is an outlier, don't worry about giving me the exact number answer. You can do that. Like if you look in the Geogebra program, if you can highlight the thing and figure out what it is or approximate it. But again, so if there is an outlier, tell me what that number is. If there's not, just say none. All right, so that covers all of this. So again, you're going to do that for each grade level. Then we're going to go ahead and talk about patterns or trends again. So if there was a distinctively higher average, maybe seniors were willing to pay a lot more for my coffee than the freshmen were, or some variation of it, or they drank coffee more often. Again, that's going to all depend on your data. So again, make sure we include some thoughtful analysis here. Then we're going to go on to the second quantitative question. So I'm going to do that exact same thing with my second quantitative question. And then lastly, so again, we have our trends or patterns in that. So like I said, maybe they pay more, maybe they drink it more often, whatever it may be. Again, that's just going to deal with your data. And then, again, there's no wrong answers with this as long as it makes sense with your data. So if I find that seniors pay way more than freshmen, if I look at the means and they're way off, right? So the seniors would pay 10 and the freshmen would pay 2. And then my conclusion is there's no real difference. That wouldn't make any sense, right? Because the data is saying it's different. The last one, and then weight at the most, so a full letter grade here, is if you had to choose one and only one grade level to market your product to, so again, what it is you're selling, which one would it be and why? Be sure to use the data you have collected and various methods of analysis which you applied to support your claim. So this is the big one here. So you pick which grade level is most marketable to you. So let's say my example here was, okay, I'm selling coffee. I found that seniors would buy it the most often and pay the most for it. So logically, I'd want to market to them. So it's okay. Having looked at my data, my seniors were willing to pay on average $2 more, so the mean was about 2 higher than the rest, and therefore they are my easiest way to make money on them, right? And then they also drank more cups of coffee per week. Now I'm just making this up. I haven't actually looked at this data because I totally made up the data. But again, you would look at your actual conclusions and then make it from there. So again, this one should probably be your longest response and explain how you think you'd make money off that and why that would be a good business model for you. So that's it. This is the entire project, and you now can know that you can do every step of this and probably have all your questions answered. But again, if you have questions, email me, my message, whatever you need. Please make sure your name is here.